Can you hear bar lines? Like when you read a piece of music, you see these little lines every so often that divide out the measures or the bars, but can you hear those? Are those actually something that's part of music, or do we just put those in to organize what we see? The answer is actually yes, we can hear bar lines, at least in a sense. Most music, at least Western music, uses a steady and consistent pulse that continues through the whole song or the whole piece of music. And that pulse is divided into what we think of as strong beats and weak beats. And those strong and weak beats are grouped into measures, and actually we can hear those in the music that we listen to. There's a word that describes this concept of how our brain takes music, sounds, pitches, and organizes them into these groups of strong and weak beats. And that word is meter. When you hear people talking about meter in music, that's really what they're talking about here. They're talking about how the beats are grouped within a piece of music. Now we can also use the term time signature. A lot of times time signature and meter are two phrases that we use interchangeably, but they're not really the same. Time signature is all about what's written on the page, but meter is what you hear. Now, ideally, what you hear and what you see should match up, but that's not always the case. In any case, time signatures are a great way to understand how beats are grouped within a measure, if we know how to read them. Time signatures are always at the beginning of a piece, and there's always two numbers. There's one on top and there's one on bottom. These numbers tell us some very important information about the music. The top number tells us how many beats are in a measure, and the bottom number tells us what type of note gets the beat. That means there are only a few possibilities for the notes on the bottom. You're never going to see an 11 down here, for example, because there's no such thing as an 11th note in our music notation system. We have quarter notes and eighth notes and 16th notes and 32nd notes, but there are no 11th notes. You can think of this bottom number as a fraction. If there's a 4 here, 1/4 is a quarter, so a quarter note would be the beat. If there's an eighth down here, then an eighth note would get the beat. Technically, we could even put a 1 down here. It would just mean that the whole note gets the beat. The top number can be any whole number, but you rarely see anything higher than 12. You can. There definitely are some songs that have time signatures like 26/4, but they're not very common. Hang on. Back up just a minute. Everything I told you is true if we're talking about simple meter. But guess what? There's different types of meter. Remember when I told you that meter is all about what groupings you hear within a song? Well, that also includes the subdivisions of the beat. You see, there are two main categories of beat subdivisions. We can either divide every beat into 2, or we can divide every beat into 3. If the big beats within a song are divided into 2s, we call that simple meter. If the big beats are divided into 3s, we call that compound meter. Everything I just explained about time signatures applies to simple meter, where we divide the beat into 2s, but it does not really apply to compound meter where we're dividing into 3s. So now to explain compound meter, I need to go back and explain all of this over again. In Western music notation, all notes are divisible by 2. A whole note can be divided into 2 half notes, which in turn can be divided into 2 quarter notes, and then into 2 eighth notes, and then into 2 16th notes, and so on. That means that every note naturally divides in half, but we don't really have any note that naturally divides into 3s. To make that work, we have to use dotted notes. A quarter note, for example, can be divided into 2 eighth notes, but if I want to notate a beat that's equivalent to 3 eighth notes, I have to use a dotted quarter note. The problem is that there is no number I can use in my time signature for a dotted quarter note. Time signatures only ever use whole numbers. To make time signatures work with compound meters, we have to redefine what the top and bottom numbers are. In compound meter, the bottom number no longer tells us what note gets the beat. It tells us what note gets the subdivision of the beat. It's saying that if you took the main beat and broke it into 3, this right here is the kind of note that you'd be left with. The top number is also no longer the number of beats in the measure, it's the number of subdivisions within a measure. Say you have a time signature of 6/8, for example. This tells us that there are 6 eighth notes in a measure, but there aren't 6 beats in a measure, there are only 2. If I take 3 eighth notes and I squish them together, I get a dotted quarter note as my beat. and there will be the equivalent of 2 dotted quarter notes within the measure, so 2 big beats. Okay, so now we understand that there are 2 kinds of meter. We have simple meter, where we're dividing all the beats into 2s, but then we have compound meter, where we're dividing all the beats into 3s. But we can even be more specific when we're talking about meter and describing how we hear these groupings. We can also describe how we group those big beats together. Are we grouping them in 2s? Are we grouping them in 3s, in 4s, in 7s? That determines the length of the measures, and it also determines how we feel the music, how we feel the strong beats and the weak beats. We can make this a little easier to visualize by putting our time signatures into a meter chart. At the top of the chart, I'm going to put simple and compound. On the side, I'll put duple, triple, and quadruple. Duple means we have 2 big beats in each measure. Triple is 3, and quadruple is 4. Now within this chart, we can start organizing our time signatures. 4/4 is a simple meter, and it has 4 beats in each measure, so we would put it down here in this box. 2/4 would go here, and 3/4 would go here. 2/4 has 2 big beats in a measure, so it's duple. 3/4 has 3 big beats in a measure, so it's triple. And 4/4 has 4 big beats in a measure, so it's quadruple. Those aren't the only time signatures we can put in these boxes though. We could also put 2/8 up here, or we could put 3/2 right here. Remember, in simple time signatures, the top note always tells us how many beats are in a measure. So as long as we have a 2 on the top, it's going to be a duple time signature. If there's a 3 on the top, it's going to be a triple time signature, and a 4 on the top is going to make it a quadruple time signature. Some of these meters are more common than others. 4/4, for example, is so common that sometimes we call it common time, and you'll often see a C as your time signature instead of a 4/4. 2/2 is also so common and so similar to 4/4 that we can notate the time signature by writing a C, just like common time, but then we're going to put a slash through it. 4/16, on the other hand, is one you might only see once in your lifetime, if ever. For our compound time signatures, remember that top number doesn't tell us the number of beats anymore. It tells us the number of subdivisions. Compound meters divide each beat into 3s, so to figure out the time signatures over here, we're going to times 2 by 3, and we get 6. All of the time signatures in this box over here will have 6 as the top number. We could put in 6/8, 6/4, 6/16. They're all going to be compound duple time signatures. In the compound triple box, everything will have 9 as your top number. Down here in the compound quadruple box, we have, you guessed it, 12 on the top for everything. So next time you run into a piece in 12/8, don't try to count it in 12 beats. It's not 12 beats, it's 4 beats. And each one of the 4 beats is going to be divided into 3 subdivisions. You would count it 1 enda, 2 enda, 3 enda, 4 enda, or maybe 1 lolly, 2 lolly, 3 lolly, 4 lolly, whatever your counting system is. But wait a minute, what about the time signatures that don't fit into this chart? What about 5/4? Where does that go? What about 7/8? What do we do with those meters, and why would anybody even want to write in them in the first place? Well, to know, you're going to have to check out my next video. We'll see you then.